We're going to look at the positive and negative linear associations from scatter plots. We have already explored the idea of linear and nonlinear functions, so we're already aware that a linear function, of course, gives a straight line. A nonlinear function gives a curve. And what we also know about the linear associations is that if that straight line is increasing from left to right, that's a positive slope. It has a positive slope, and therefore it has a positive linear association. A negative linear association would have a negative slope on that line. The one extra one here you see is no association. Well, that's where there's no obvious pattern at all to the data. So those are our options, and all we're doing right here is looking at the general characteristics of a scatter plot. So let's take a look at this scatter plot right here. Okay. Now we have four options. You can see positive linear association, negative linear association, nonlinear association, or no association. And what I want to show you here is this data here is all just clumped in together. There's no clear pattern to this. It doesn't make a line that goes straight up and down, and it doesn't make a line that goes downwards. There isn't really any curve. I mean, you've got a rough curve that might look like this, but all the data is far too spread out from here. So it doesn't give you it doesn't really give any association at all. So we can select no association for this one. And again, a similar situation to this one here. We have no real association. Could you potentially have some sort of a curve that runs through it like this? Yes, I guess you could, but there are too many outliers to the data to be able to accurately predict an association in this data here. Again, so this is all we're doing in this exercise is deciding what kind of association there is to the data. Okay, here's one that should illustrate a nonlinear association a little bit easier. You can see it's not a line, but there is a clear pattern, and our pattern is decreasing for a long time. There is an inflection point right there, and then it increases again. Okay, so we have a curve here. This is a nonlinear association. It is just a scatter plot, so it's just a plot of data that's just plugged in on a graph. But when you put it on the graph, you can see a clear pattern, and this clear pattern is a nonlinear association, but it is an association that we can actually work with and we can hypothesize from. Our last example here isn't entirely clear, but we can, when you first glance at it, you might think, well, there's no association here. They're far too spread apart. But this is the whole point of scatter plots. Scatter plots can have outliers. The whole point is that there aren't any major outliers. There aren't a majority of points that are outliers to a pattern that you're looking for. With this particular one, we can see that there is a general trend to the data. The initial part of the data is all up here in the 80 and 70 in the life expectancy, right? It then moves down to between 75 and about 55, right? And then it moves down again from about 65 down to about 40, and finally you've got one last piece right there in that same range, okay? But clearly, the data can almost be put into boxes. And if you put this data into boxes, the boxes are moving in a particular linear direction. Okay, so this here is what we would call a linear association. And because that general direction of the data is trending downwards, we're going to call that a negative linear association. So I hope I've given you enough information there to attempt this for yourself. If you've got any questions, let me know, and try it out for yourself. See how you get on.